3, 2, 1. Here we go. Okay. Today's a little bit more challenging than yesterday. You got to really lean in here. Okay. The two pieces, we don't have time to go through the proofs. More of a calculus 2 topic anyway. But we want to determine the derivative of the natural log function. Okay. And so yesterday you learned that the derivative of e to the x is e to the x. Again, the relationship between e to the x and natural log of x is that they are inverse functions. We did that review last Friday, right? What's the shape of the e to the x graph? Yeah, what's the shape of the natural logarithmic graph? Good. She knows. And so they are inverse functions. The derivative of natural log of x happens to be 1 over x. 1 over x. Okay? So again, this adds to the list of the number of derivatives you're going to memorize for your next test. And then, what is the base of natural logarithm? E. Base is e. But you won't really use this very much, but I'm going to just show you the derivative of log base b. So if the base is not e, then the derivative is 1 over x times the natural log of base b. I think I just have one example on here where it's like that. We good?
Yes.
Jojo? Yeah. Hey, you're yawning. You're making me feel like I'm boring right now. Okay. All right, great. Okay, so here's the piece. And so you guys are really good at being able to carry out problems when I show you exactly what to do. Within these logarithmic differentiation pieces, you get to explore a number of different ways of carrying these out, and that would be really up to you. So I'm going to show you 2 ways to do this first one. What differentiation rule do you think we use for this first one right here? What comes to mind for you? Chain rule, yeah. So if I write out the chain rule, I'll use the boxes, and I have the natural log of u, and I have 1 over x squared, which I'll choose to write as x to the negative 2 power. What is the derivative of the natural log of u? 1 over u, thank you. And the derivative of x to the negative 2? Negative 2 over x cubed. Good. And so as I look at this derivative, I have 1 over x to the negative 2 times negative 2 over x cubed. So notice that the negative 2 sits in the denominator. I can bring it to the numerator and say we have x squared over 1 times negative 2 over x cubed. And in the end, you end up with negative 2 over x. That is the derivative. Everybody good with that? Mm-hmm. Yes, sir.
Why is the natural log 1 over u?
So it is that because we defined it to be that way. The derivative of the natural log of x is 1 over x. If you want to see the proof, it's a good 35-minute proof. We won't go down that path. I could give you a video if you want. Should I shoot it your way? Just like yesterday, we said that the derivative of e to the x is e to the x, and we accept that as just fact and truth. Same piece here. But it's a little bit involved to see that the derivative of natural log of x is 1 over x. Not sure it's worth our time. I did show you guys that the derivative of sine is cosine, and we looked at that piece together. This one, not so much. Okay, so you don't have to redo it here, but what I would like to do is I'd like to show you a different way of doing it, because I don't do the problem like that. Okay? And everybody kind of has their own ways, but I don't like that option. Okay? Can I show you my option? Okay, here's my option. Oh yeah, I think it's way easier. Okay? And so I write this in this way. I write the natural log of x to the negative 2. Is everybody okay that the natural log of 1 over x squared is the same as the natural log of x to the negative 2? Yeah. So I've not taken a derivative yet. I've just rewritten it. In fact, I'm going to rewrite it again. Notice I have not taken a derivative. I'm just going to rewrite it. Who knows what I could do with the property of logarithms in this situation to make the problem look a little different? Yeah, just drop that negative 2 out front, right? If you have a power within a logarithm, just drop the negative 2 out front. Negative 2 times the natural log of x. And now I'm going to take the derivative. What's the derivative of the natural log of x? 1 over x times negative 2 is negative 2 over x. I think that that's easier. So using those properties of logarithms, very, very, very important. What's that? Usually people say it looks like voodoo math at this point, but so.
No.
All right, we try the next one. In this situation here, you can do the same thing. We have f prime of x is equal to, notice you have e to the 2x. So what can I do with the 2x? I can bring it out front, can't I? 2x times the logarithm base 4 of e. Isn't the log base 4 of e just some constant, some value? And so what is the derivative of 2x? So we have 2 times the log base 4 of e. Let's look at example C. What rule do you think we have to use here? Quotient rule, okay? So let's use the quotient rule, f prime of x. No easy way to get around this one, no way of rewriting it. What's the derivative of the top? 1 over x times e to the x minus e to the x times natural log of x divided by e to the x squared, which is an e to the 2x. Okay. What could you factor out of the top? You could factor out an e to the x. E to the x times a 1 over x minus the natural log of x divided by e to the 2x. What happens? Yeah, one of the e to the x's will reduce. So that reduces with one of these. So I have 1 over x minus the natural log of x over e to the x. Can I leave my answer like that? No, we've got a complex fraction, don't we? So we're going to have to deal with this complex fraction. You won't ever see the answer expressed in that fashion. So this is over 1, so I'll multiply top and bottom by x. I'll write the bottom over 1. So now we have the derivative is equal to, what's the top numerator? 1 minus x natural log of x over x over e to the x over 1. Great. So now I have my 1 fraction over 1 fraction. I multiply by the reciprocal. And when you do, notice that e to the x will simply just join in the denominator. The answer is 1 minus x natural log of x over x e to the x. Okay, not too bad. I believe I posted the answer key online this morning for yesterday's assignment. And for the velocity and acceleration one as well. Okay. So this one looks really scary. Okay. We forgot an f of x here. We'll write f of x is equal to. We have the natural log of the quantity x plus 2 to the 4th times x minus 3 to the 10th. We got to find that derivative. I would like you to understand that if we were going to do this, we would have to set the chain rule with the product rule with 2 chain rules. That's way too much work. Way too much work. So what you need to see when you see this is you need to see that you can rewrite this. Rewrite this. See if you can take about a minute, work with the person next to you, try to rewrite this, and you're going to end up doing something with the fact that there's multiplication and powers. Okay? So use your laws of logarithms to try to rewrite it. Give it your best shot. Go. See what you come up with. Try to rewrite it.
40. 40. Four times 10. I made that up. It might not be right, but that's okay. So here you move the 2x down in front.
But this is still. Well, yeah, I wrote this, because I don't know. But then,
That's just highly illegal.
it's kind of you to get out of it. Yeah. Does it have to stay in parentheses?
So because these two things are being multiplied together, you should separate them as addition.
Oh, and then we can move them 4 and 10.
So natural log of x
So because those two
plus
things
4
multiply together.
plus the natural log of x minus 3 to 10. And
Oh,
then move 4
yeah, I
times
forgot about that.
4 natural log of x plus 2
Oh, good.
plus 10 natural log of x minus 3.
Because these are two
Like that?
multiplied together, this is addition. I'll write it out. Good, yep. Okay, let's give it a shot. Okay, so what you have to be able to see here is this is the natural log of x plus 2 to the 4th power plus the natural log of x minus 3 to the 10th power. So you could take a product that sits within a logarithm and separate it into two logarithms using addition. That is the product rule for those laws of logarithms. Now, this is what everybody's focusing on. Now what can you do?
Drop 3.
Yeah, bring the 4 and the 10 out front, right? So you have f of x. Notice I'm just writing f of x because I've not taken a derivative yet. 4 natural log of x plus 2 plus 10 natural log of x minus 3. Okay? Now, that's a lot easier problem for us to deal with. Okay? Much, much easier. Because when we want to take these derivatives, we just have to set up the chain rule for each one. Okay? And what sits on the inside is x plus 2. So what's the outside?
4 natural log of u.
4 natural log of u. And so the derivative of 4 natural log of u is 4 over u. And the derivative of x plus 2 is 1. So you get f prime of x is equal to 4 over x plus 2. Now, I think that some of you will catch on to this. If you look here, it's set up just the same. But if you notice, the derivative of x minus 3 is just 1. So notice that if the derivative is just 1, it works out pretty nicely where it's simply just the constant over that piece. So can anybody see what the derivative here is going to be? Yeah, 10 over x minus 3. So that only works if the derivative of that inside is 1. So if you have a linear piece like that, it's going to work out rather quickly. If you've got a 2, then obviously, you're going to have to multiply by 2 and so on and so forth. So but that's a derivative. I think that's a lot easier than setting up the chain rule with the product rule with 2 chain rules on the inside. Don't you agree?
Yes.
So again, remember that last year when we were working through logarithms, so many times people were like, well, what's e to the x? What's natural log of x? Why do we do this? It feels like fake math. Remember, last year's class is primarily called pre-calculus. It's to prepare you for these moments. Those laws make this a lot easier. Question?
Do we have to make a common denominator for that? Or
Absolutely not. Leave it. You're done.
Okay.
Yep. No. All right, flip it. What now? Okay, so that's the 1/2 power. Chain rule with the 1/2 power. I like the way you guys are thinking here. So I'm going to write this as u to the 1/2 and then the natural log of the quantity 2x minus 1. The derivative of u to the 1/2? 1 over 2 roots of u. How do I determine the derivative of natural log of 2x minus 1? Chain rule again. So I have the natural log of u, and I have 2x minus 1. The derivative is 2. The derivative is 1 over u. So again, you can predict pretty quickly how these derivatives are going to turn out. You don't have to set up the boxes every single time. You can see that because the derivative of the inside is 2, you get 2 over 2x minus 1. And now it's time to multiply these together, isn't it? And what happens when we multiply them together? Yeah, these 2's will reduce to 1, and we get 1 over the natural log of 2x minus 1 times the root of, well, I'm sorry. Yep.
Yeah.
No, I know. Don't make me feel bad. So we have 1 over 2x minus 1 times, and then we put the natural log of 2x minus 1 in for the square root. So we have square root of natural log of 2x minus 1. There we go. You guys okay with that? Oh boy, oh boy, oh boy. Letter F. Try again. Try to rewrite this. Rewrite it. Don't take the derivative right now. Don't use the quotient rule. Talk to your friend. Try to rewrite it.
I actually made that very clear today, and it really hurt my heart.
So what I would do is, again, when you're dividing, you're going to use subtraction. So it's the natural log of x minus the natural log of x.
Yeah, I moved this up to the top. Why? Because I could just make it a negative.
Well, most of it.
I mean, I could just go up to next.
Did you have dividing?
You just subtract it. I got the same answer, so it's okay.
Okay, that's fine. Yeah, fine.
So on the one back here, where it came and told me to do, when we split it into two for addition, you split it into two, but instead of multiplying.
Okay, eyes up. I saw the dividing sitting within a logarithm. And at that point, something's got to indicate in your brain, hey, I'm going to go ahead and separate these using subtraction. So therefore, I have f of x is equal to, again, the natural log of x. Now I can bring the exponent out front, 5 natural log of x squared minus 2x plus 4. So now the derivative becomes very simple. We have f prime of x is equal to, we know the derivative of natural log of x. What is it? 1 over x. That was super simple. And now for the next part, we can just use our fancy dancy chain rule, which is super amazing and awesome. So we have, I'll use my subtraction sign there. So I have a 5 natural log of u, and I have x squared minus 2x plus 4. What's the derivative of 5 natural log of u? 5 over u. And then the derivative of x squared minus 2x plus 4 is 2x minus dos, which is Spanish for 2. So I would have f prime of x is equal to 1 over x minus, what's in the top? Thank you, Jojo. Over x squared minus 2x plus 4.
And that's it.
Lily, can you say that louder,
I
please?
said, so we still don't find a common denominator.
Right. So back in the day when you were in college algebra, we were saying, hey, combine your fractions, find common denominators. There was a purpose behind it. And so where these derivatives end up leaving you, it's not necessarily any more helpful for us to find a common denominator here. Well, you could, but the expression that you get is not any more helpful. So suppose that this was a problem on the test. Suppose that this was your position function, and suppose that you were then producing a velocity function right here, okay? If you were working with that velocity function, you would just type that into your calculator and use your calculator in that situation. Your calculator doesn't care if has common denominators or not, does it? And so that's where we're at, okay?
So if you ever want us to have a common denominator moving on, you'll like make it in instruction.
Yes, I've been pretty clear that if you, for example, you guys have gotten used to the fact that if you can factor out a common factor in your answer, that's something that we should try to be consistent with. And so we've done that in different scenarios. Like here, you know, we reduce the e to the x, so on and so forth. But I'll try to be very explicit, okay? Yes, okay. All right, 2 more problems. Good job. Excellent question. Thank you for asking, Lily.
You're welcome.
How's the dog?
It's plural.
How are the dogs?
They're really
Okay,
good.
we haven't seen them for a while.
It's almost their birthday.
What?
Well, we'll be fine.
Christmas.
Christmas
You're right.
Eve.
You're right. Christmas.
Okay, how do you want to approach this
Not
one?
quite all.
How do you want to approach this one?
We use the subtraction.
Quotient rule. There's no really option. If this was so, just to be clear, when people see division, they all of a sudden think subtraction right away. If this was the natural log of x or 5x plus 3 over 4 minus 2x, then we could write it as subtraction. But see how that's one logarithm? You break it up into two. You don't have one logarithm here. Get my point?
Yeah.
So we just need to resort to using the good old quotient rule, okay? No easy way around this. We're just going to have to do it. So we take the derivative of the top. What's the derivative? 5 natural log of x. 5 over x. And what's the derivative of 3? 0. Isn't that fun? Times 4 minus 2 natural log of x. So multiply by the bottom. Then what?
Then you minus.
Minus the derivative of the bottom. The derivative of 4 is 0. And the derivative of negative 2 natural log of x is negative 2 over x. So I'm going to write as plus 2 over x times 5 natural log of x plus 3. That all sits over 4 minus 2 natural log of x, that quantity squared. What would you do?
Do you have to do anything?
Yes, you have a complex fraction.
Oh, yeah.
And so part of it is like, well, you could just type in your calculator. Calculator is a care. I get your point. But so part of what I'm trying to get you is as you take the AP exam, they will never express that in that form. And there are things that do reduce. They simplify.
Distributed 5 over x.
Okay, yep, let's just go through the nasty distribution process. F prime of x is equal to, looks like we're going to have a 20 over x. And then where you have a minus 10 natural log of x over x. Plus what? 10 natural log of x over x plus 6 over x. Isn't that nice? You see that the negative 10 natural log of x over x and the positive 10 natural log of x over x will reduce. And the denominator, 4 minus 2 natural log of x, that quantity squared. So we'll divide those off or subtract those from each other. They're gone. And in the top, we get 20 over x plus 6 over x. I get 26 over x. Divided by the quantity 4 minus 2 natural log of x squared over 1. So now I'm going to get rid of that complex fraction, and I end up with the derivative of f is equal to 26 over x times 4 minus 2 natural log of x quantity squared. I like that problem. Okay, last one. Write an equation for a line. You hear these directions, what do you first think about? Slope and a point. Thank you. M and a point. The equation looks very interesting. 3e to the 2x plus x, natural log of 2x plus 1. Wow! At x equals 0. You see this question, you're like, oh, thank you, AP examiner. Thank you, Mr. Getz. You gave us an x value of 0 because we like working with 0. A lot of times things work out quite well for us. We'll see if you can determine then, how do I find my y value for my point? Plug it in. So I have 3e to the 0. What is 3e to the 0? What is e to the 0?
1
Times 3 is 3. So you get 3 plus, and notice how you have 0 times whatever is left, don't you? Can everybody see that? We are going to get 3 out of that. Okay. So again, AP exam, very common for doing that. Giving you an equation that looks rather challenging, allowing you to plug in 0 and arriving at a nice value. So we already know the y-intercept is 3, so that's helpful for us. How do I find the slope? take the derivative, right? When in doubt, just derive it. So we have f prime of x. This can build off of what we had yesterday. I'm going to give myself a little bit more space. I can see this is going to get a little lengthy. Anybody from yesterday, the derivative of e to the 2x?
6e to the x, or 6e to the 2x.
It is 6e to the 2x. I'm going to write it down, and then I will write it out in case you were curious. Again, you have 3e to the u, and you have 2x. The derivative of 2x is 2. The derivative of 3e to the u is 3e to the u. So hopefully everybody can see we get a 6e to the 2x. We did talk about when it is e to a power, you simply just have to take the derivative of that power and drop it out front. Plus, now what do we do? Product rule. Why, Hannah? Or why, Lily?
Because there's two x's.
Yeah, because it's x times that function. Good. So I'm going to call this f. I'm going to call this g. So the derivative of x is 1. So then we just have the natural log of 2x plus 1. Plus, then we have f times g prime. So x times, and the derivative of the natural log of 2x plus 1. Close. You have the natural log of u, and you have 2x plus 1. You are right, Aiden, that the derivative is 2, but in this situation, you have to make sure you plug the 2x plus 1 back into the bottom. You see that? So we get 2 over 2x plus 1. Is the problem asking me to write this in simplified form? No, it's only asking me to produce a slope. So what should I do? Just plug in 0 at this point and see what happens. E to the 0 is times 6 is 6. If I plug in 0 here, I get the natural log of 1. Who remembers from Friday what the natural log of 1 is? It is 0.
Plus 0. So it's 6.
Plus 0. So we get 6. Isn't that great? Cool. So the slope is 6. The y-intercept is 3. Y is equal to 6x plus 3. Piece of cake, upside down. Okay, before we celebrate that you're done with that piece, that's what we need to do tomorrow. So we need to figure out the inverse trigonometric function derivatives. Those will be the last set of derivatives that you have to memorize for the test. You will have a day to work. I'll get you a study guide tomorrow. We'll give you some time to work on Friday or Thursday. Friday. I think on Thursday, I think we're going to do our first AP review. Okay? And first AP review, I'm just going to give you an assortment of problems to try. We'll probably do multiple choice, and you can start to see what some of those questions are like. Okay? Do you know what a good score is on the AP exam? Don't say 1, 2, 3, 4, 5. Do you know percentage-wise what a good score on the AP exam is?
58.
If you get like about a 65% of the test, that's a 5.
What about like a 25%?
25% will get you a 1.
Okay.
About a 35% can get you a 2.
How much is a 3?
A 3 is about 40 to 45%. So
I think I can get a solid 30%.
that's what most people say, but as we will frame it tomorrow. I want to warn you guys, and this is kind of the the issue that I have over the years. Is a hard test, and so when we get to kind of doing the review piece, got to just kind of reduce your expectation. I mean, have I ever given a test here where the highest score in the class was a 70%? Absolutely not, nothing even close to that, right? But trust me, if somebody here scored 70% on the AP exam this next spring, that would be an exceptional
Everyone
score.
needs to go potty.
Okay.
Yes.
All right, you guys can get started on your